Hello, in this recording, we're going to use the number line to determine the relationship, and by that we mean relative sizes between different numbers. And we're going to use these symbols, the less than symbol, the greater than symbol, the less than or equal to symbol, and the greater than or equal to symbol. And we're going to confine ourselves to those symbols. So whatever relationships we discover, we're going to have to figure out a way to describe them using those symbols. So my first recommendation is that we use the number line to get kind of a picture of what the relationships are. So for each one of these, I'm going to just sketch out a number line. I'm going to make sure my number line includes space for each of the numbers. So it's always nice to define where 0 is on a number line. My first set is 5/4, 4/5, and 1. I don't have any negative numbers, so I'm going to put 0 over here on the left side. Then I'll put 1 somewhere over here, and then maybe I'll put 2 in there. Now, I kind of could see what was happening here. If I think about this, the first number is 5/4, so I need to count by fours. So 1, 2, 3. It's not terrific, but there's cutting the space between 0 and 1 into fours, and then 1, 2, 3. So 4 spaces between 1 and 2. So now I'm counting 5/4. I can see that 5/4 ends up being right here. 5/4. That's a little bit more than 1. You can see the 5 on top, a little bit bigger than the 4 on the bottom, so you kind of knew that was 1 1/4, right? Okay, so there's 5/4. We already have the 1 there, and then 4/5. Now that's a little bit harder, right? I've already marked off 5/4, so now I need to cut the spaces into fifths there. I could do that. It's not super important that I do this. Fifths, 1, 2, 3, 4. So I've kind of broken up my spacing into fourths, and they don't really make a whole lot of sense compared to my fifths and compared to the fourths. But 1/4, 1/5, 2/5, 3/5, 4/5, 5/5 is the 1. So 4/5 would be a little bit less than 1. So let me go back to my blue here, and we'll just say there's about 4/5. It's a little bit less than 1, and 5/4 is a little bit more than 1. And so the space between 1 and 4/5 is 1/5, and the space between 1 and 5/4 is 1/4, so a little bit bigger than 1/5, but it's fairly accurate actually. But you can clearly see now that from smallest to biggest, my numbers are 4/5, 1, and 5/4. And if I'm going to use these symbols, I could use the less than symbols. Right? 4/5 is smaller than 1. 1 is smaller than or less than 5/4. So there's one way that I could answer the question. Now I could have done it the other way. I'd go from biggest to smallest. So 5/4 is greater than 1, which is greater than 4/5. That would maybe not be the standard way to show this. Usually we like to go from smallest to biggest, but both of those answers are correct. All right, let's do that again with -3, -7. Now this is one of our trick questions. It's always good to use a number line when you're dealing with negative numbers, because mentally just when you think about this really fast, you want to say that 7 is bigger than 3, right? And it's so true. Like we're just so conditioned to say 7 is bigger than 3. Well, I don't have any positive numbers, so I'm going to put 0 on the far right side of the line because I don't have anything positive in my set of numbers here, so I need lots of space in the negative. So I need lots of space to get to 7. So I'm going to go 1, 2, 3, 4, 5, probably didn't, 6, 7. So 8, 9, 10, wow. So -10 is there. 1, 2, 3, 4, 5. -5 is there. And now I can plot my points here. So -3 would be 1, 2, 3 would be right there. There's -3, and 4, 5, 6, 7 would be right there. So it's so tempting to say that -7 is bigger than -3 because it's further away from 0. That's what the 7 means. It's further away from 0 than 3 is, but because it's further to the left, we say that -7 is less than -3. Or again, we could have said -3 is greater than -7. Now, I didn't say this on the last one, but it would have been just as correct to say that -7 is less than or equal to -3, and -3 is greater than or equal to -7. Now, remember, the equal to part is an or statement. It's either less, -7 is either less than -3 or it's equal to -3. Now, we know it's not equal, but we can still use the less than or equal to symbol because one of the two is correct. So just a little funny trick there that we're allowed to use that symbol even in the case where the equal part is not true. We're going to see in just a minute the reverse of that situation. Okay, so my last one, number 3, I've got two negative numbers. Let's see, so I'll put my 0 there. Both of those numbers are less than -1, or can between 0 and -1. So I can put -1 over here. And let's see, one of them is 1/2, which is halfway between 0 and -1. So there's -1/2. The other one is -0.5. Well, wait a second. -0.5 is the same as -1/2. So both numbers are the same number. -0.5, -1/2. So technically, -1/2 and -0.5 are equal to each other. But look back at the directions. We were not given the option of equal. So we need to come up with a symbol to put in there that says that they are equal to each other, and the only symbols we have are the less than symbol, less than or equal to, or the greater than or equal to. So either -1/2 is less than or equal to -0.5, or it's greater than or equal to 0.5. So both of those answers are correct within the confines of this question. We were told, make a statement using an inequality symbol, but they aren't unequal, they are actually equal, so we need to use the one that allows for them to be equal. All right, that's kind of a silly question, but thank you so much for watching.